Okay, so I've got the observation tower question, and it says Val is 50 meters due north of a communications tower. The top of the tower is at an angle of elevation of 41 degrees from the ground at Val's observation point. From Con's observation point, is due east of the tower, the angle of elevation of the top of the tower is 29 degrees. Find Con's true bearing from Val's observation point. The question provides a diagram that can be difficult to work with because it is cut off by the text. Students may choose to redraw the layout in a typical north-south orientation to show Val and Con's position in relation to the tower. For Val's position, there is an angle of elevation and a side given. For Con's position, there is only an angle of elevation given. The question states that the angle of elevation is from the ground of the observation point. To clarify the view, it would be expected from the students to state whether the diagram is plan or side view in each step. Students need to find the height of the tower using Val's measurements as there is an angle and a length given. This means that students will need to apply trigonometry to solve a right angle triangle. Students will need to identify to use the tangent function given that the angle and adjacent side are known and need to find the opposite side. So let t be the height of the tower, and we know that the distance between Val and the tower is 50 meters and the angle is 41 degrees. So substituting these values into the tangent function and rearranging to solve the value for t. When we do this, we find that the height of the tower is 43.46 meters. The height of the tower is constant for both Val and Con. Therefore, two of the parameters for Con are now known. The students can apply trigonometry to solve a right angle triangle, more specifically the tangent function, to find how far Con is away from the tower, since the opposite side and angle are now known and need to find the adjacent side. So let d be the distance between Con and the tower. And we know that the height of the tower is 43.46 meters and the angle is 29 degrees, so just need to simply substitute these values into the tangent function and solve for the missing value of d. So d equals 78.4, meaning Con's distance is 78.4 meters from the tower. Students will need to recognize that to find the angle between Con and Val, they will need to calculate the angle from Val's observation point. Now that it is known how far Con and Val are away from the tower, students need to use the inverse of the trigonometry function for tangent, being arctangent, to find the angle between them. Substituting the opposite value of 50 meters and adjacent value of 78.4 meters into the arctangent function to find an angle of 32.5 degrees. Step 5. The students will now need to recognize that the angle that is found is an alternate interior angle and should prove this with a diagram. This is because two lines are crossed by another line known as a transversal. The pair of angles are opposite side of the transversal and both interior of the two crossed lines, meaning they are alternate interior angles. Students will need to use knowledge of true bearings to start from the north line and move in a clockwise direction until the line between Val and Con is reached. Students need to calculate Con's true bearing from Val's observation point by adding the angle found with 90 degrees. Students should state after they're working out in a word response that Con's true bearing from Val's observation point is 122 degrees. Providing a diagram will help clarify working out an explanation. Although the question doesn't state that students should add an assumption and effect type response, it is something that should be expected of an A-level student in this case. For example, students should recognize that it is an assumption that the angle between Con and the tower is from the ground rather than eye level as stated for Val, otherwise the distance would be slightly different.